All right, so right now, we're going to talk about the derivative, okay? So the derivative is also known as, so they might give it different names. Like one of them that you might find is a lot of times they'll tell you to find the slope of a line or of a curve at a specific point. In order to find that slope, you would take a derivative, right? Derivative also means whenever you see the terms rate of change. Okay, so rate of change also means you're probably going to be taking a derivative. Now, there's a whole bunch more. There's optimization, relative extrema, local extrema, absolute maximum. There's related rates. There's maximums and minimums. Tons of other terms that we're going to learn throughout the year that mean take a derivative. Okay, but for now, we'll start off with these two. Okay, whenever you see slope, actually, I could even tell you another key word, one that I just thought of right now that could probably help you out, is whenever you see the word tangent, right? Find the slope of a tangent line. So whenever you see the word tangent, a lot of times people are thinking derivatives, okay? Um, but this is just some of the different ways that we're going to kind of discuss derivatives. You might see different words that mean take a derivative, okay? Now, let's start off with one of the basic rules for derivatives, the constant rule. So the constant rule basically says d dx of c is equal to 0. Now I'll translate this. Like if you were to read this, this is saying the derivative let me erase that. The derivative of c with respect to x is 0. So let me see if I can kind of highlight some stuff here. The derivative of okay, that's what that means. C is pretty self-explanatory. With respect to x is 0. So on the bottom of that fraction, the ddx as people will call it, there could be a ddy, a dda, ddb, right? It just depends on what letter you're taking a derivative of. A constant does not have variables. It's just a number, like a 2, a negative 13, a 7. So it doesn't matter what letter I take a derivative of a constant with respect to. I could do like d dt of 5. That's 0. Right? I could do d dy of negative 3. That's 0. Okay? As long as it's a constant, then its derivative is 0. Okay? The derivative of a million is 0. Okay? Why is that? Well, if derivative means slope, right? Derivative means slope. And I want you to take the derivative of a function 5, like y equal to 5. What does the graph of y equal to 5 look like? Say it louder. A straight line, horizontal or vertical? Horizontal. What's the slope of a horizontal line? 0. So does it make sense that a derivative of a constant is 0? Yeah, because if you graph any constant function, it's a horizontal line. Horizontal lines have slopes of 0. Therefore, the derivative of a constant is 0. You're finding its slope, right? So that's why we have that constant rule, okay? So it's just saying anything that you do that has a constant value and you're going to take a derivative for it is going to be 0. Okay, so that's the constant rule. So let's talk about the power rule. There's actually one of the most important ones. I mean, there's a lot of other rules, but power rule shows up pretty much all the time. So this one actually has some prerequisites here. It says if n is a rational number, okay, and just so that you know, in math speak, a lot of times in books, they'll write it like this. That's what that means. N is a rational number. Okay, so that's just shorthand. So if n is a rational number, whoops, sorry about that, wrong color. Then the function f of x equal to x to the n is differentiable. Now, to be differentiable means that you can take a derivative of it. So the function is differentiable. And so here's our derivative for that function. So d dx of x to the n is n times x to the n minus 1. Now I'm just going to give you a special case here. All right, I'm not going to give you the answer to this. I want to see if somebody can think about it really quick. What would be d dx of x? Okay, what would be the derivative of x? Now, x is a function. D dx means slope. Uh-huh. 1. It's 1. Yeah. Because the function y equals to x is a one-to-one function, right? The points are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, right? So the slope is up 1 over 1, right? So it's 1, positive 1. So my answer would be 1. See, so we're just trying to find slopes so far, and you've seen that the slope of a constant value is 0 because a constant value is a horizontal line. The slope of a linear function like x would just be 1, right? And then the slope to any other type of function with different powers, right? X squared, x cubed, etc. What you have to do is bring down the power and then subtract 1 from the power. Okay, so you're going to bring down the power and subtract 1 from the power. I'm just checking time real quick. All right. So let me give you an example here. So we're going to differentiate. For part A, I'll leave that there. Now there are two ways that you can write this, okay? if you're going to take the derivative of y, you can either write it like this, dy dx. In other words, I'm going to take the derivative of the function y with respect to x. Or you could write it d dx of x squared. I'll tell you that about 90% of the population will stick to the left side, not the right side. We prefer just writing dy dx. If y is x squared, then dy dx is the following. Okay? More people like that, dy dx. Not that the one on the right is wrong, it just looks a little bit more messy, right? So I'd rather stick to something that looks a little more easy to read, right? dy dx, not d dx of x squared, right? So according to my definition of how to take a derivative of something with a power, I'm supposed to bring down that power, so the 2 goes down here, and then multiply it times x to the 2 minus 1, right? I got to subtract 1 from the power. So, well, 2 minus 1 is 1. I have a 2 in front, so it's just going to be 2x. That's my derivative. Now, remember what we called this before when I was kind of going over this with you guys in chapter 1. This is what we call our slope formula, okay, for the function x squared, right? 2x is how I find the slope for any point on the function x squared. So all I got to do is just decide what point I want to figure it out at, and it'll give me that answer. Now, some of you guys have calculators that might actually be able to do that for you. They can calculate the slopes at specific parts of your graph. I know Casio's can do that. I'm not sure if the newer TIs can do it. I haven't played with those enough to find out. By the way, on the right side, you still do it the same way. So it's not like you're losing anything by choosing to do it the other way. It's still the same answer. Okay, so don't feel like, oh, I can't do this because you said it's going to be too hard. No, it's the same thing. No difference. Okay. Now here's another part, another differentiation problem for you. Now this one's a little different because if you think about it, I've only shown you guys 2 rules, right? I've shown you the rule for constants, and I've shown you the rules for powers, but I never showed you a rule for fractions, okay? Or anything like that. There is no fraction rule that I showed you, at least not yet. There's no quotient rule yet. There is one, but I haven't shown one to you yet. So I can either just take a derivative of a constant, or I can take a derivative of something with a power. Right now, there's something with the power there, but in the denominator. So what I'm going to do is I'm going to rewrite it. I'm going to write it as x to the negative 2. That's the same thing, right? It's just a reciprocal kind of, right? Just rewriting it. Not reciprocal, I'm sorry. Just a way to rewrite the power, right? So now that it looks like that, I can actually take a derivative of this. Now you could, and I'm not going to advise you to do this, but you can do d dx of f of x. I mean, that's fine. Or you can even write like d dx of x to the negative 2. That's fine too. But I would recommend f prime of x. This is the other one that's highly used. dy dx and f prime of x and y prime, though y prime is not as used as often, but f prime of x and dy dx are the most common ones. Okay, you can use the ones in green. They still do the same thing. It still means that you're taking a derivative of f of x, or you're taking a derivative of x to the negative 2. But most people say, well, here's my original function, here's now my derivative, right? So f of x and f prime of x. Now, I got to take the power down. So this is negative 2 times x to the negative 2 minus 1. Well, that's a negative 3. So that's negative 2 times x to the negative 3. That means that f prime of x is negative 2 over x cubed. Let me just check something here. Here, I'm just going to give you something here, just for you guys to try. Go ahead and take a derivative of that. I'm going to pause the video just so you guys can take a little bit of time on that. All right, anybody have an answer for me? 4x cubed is correct, yes. So yeah, f prime of x, drop your 4, x to the 4 minus 1. By the way, you don't have to show the work when you do this, just so you know, you can do it in your head. So f prime of x would be 4x cubed. So this is where we'll stop for today. Tomorrow we'll continue. I don't know if we'll finish it, but we'll get close.